current. So, so once again, I explained Ohm's law, activity one, lab activity one, and lab activity two else. Okay. So here, lab activity. Lab activity one. Okay. Okay. Lab activity. Electric. 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 Here in the chapter, so we have what we have in first activity. In first activity, we have the situation number one, situation number two, situation number three. We have in first situation and first situation, bulb is connected to battery through the switch. Circuit is closed circuit. Wires are non-insulated. I mean, non-insulated copper wires. Copper wires. Circuit is closed. When we switch on, the bulb is glow in the first situation. Second situation, battery removed from the circuit. The circuit does not have battery. Battery. The bulb is not glowing. In the third situation, wires are replaced by the nylon wire. Nylon wire is an insulator. Insulator does not carry current, does not carry energy from battery to bulb. That's why. In the third situation, bulb is not glowing. That is a cases. Next, electric current. Electric current. Electric current means we know very well closed circuit, open wire, closed wire. In the open wire, we know very well our scientist drew and Lawrence in 19th century. In 19th century, so they were proposed to conductor like in metal. Metal have having number of free electrons. This number of free electrons are moving in the different directions, moving in random directions. All electrons are moving in the random direction, different directions, different directions. And so we take the one cross sectional area. We take the cross sectional area. Number of electrons crossing cross-sectional area from left to right in a second is equal to number of electrons crossing cross-sectional area from right to left in a second. Both are equal. And net charge, total net charge crossing total net charge crossing any cross-sectional area in a conductor is that is 0. That means open wire. Suppose we are touching open wire, we are not getting any shock from that wire. That is an open circuit. Next, closed circuit means closed. The wire is connected to one end of the one end of the wire is connected to positive terminal of the battery. Another end of the wire is connected to negative terminal of the battery. The circuit is closed. The circuit is closed, and current flows from negative charges. Negative charges are moving from negative terminal to positive. So current flows from positive terminal to negative terminal. Electric field set up from positive terminal to negative terminal. So drift velocity set up from negative terminal to positive terminal. So you take any cross-section area, all electrons are moving from negative to positive in certain direction, particular direction. So battery is connected to two ends of the wire, means electric field set up throughout the wire, throughout the length of the wire. So battery, positive terminal of the battery is connected to one end of the connector, negative terminal of the battery is connected to another end of the connector. Immediately electric field setups from positive terminal to negative terminal throughout the wire. Yeah, all electrons are moving in a certain direction by the electric force. Electric force exerts a force on the electrons. All electrons are moving in a particular direction. Okay, so that is a closed circuit. And the next drift velocity. We have a drift velocity. That is I is equal to Vd via V value. That is V, and I means current, N means charge density for volume, and Q means charge, and electron, maybe positive electron, negative electron. Next Vd means drift velocity. That is next potential difference. Charge moves from one point to another point in the electric field. There exists potential difference. That is a potential difference. Next EMF means work done by the chemical force acting on the negative ions moving from positive terminal to negative terminal is called as EMF. Otherwise, work done by the chemical force acting on unit positive charge, that is moving from negative terminal to positive terminal, that is EMF. EMF potential difference or not same. So it is denoted by the letter Pd and V. Okay. So we know voltmeter. What is the use of voltmeter? Voltmeter is used to measure the potential difference across any part of the wire. So this voltmeter should continue parallel. The voltmeter is not connected in a series. Voltmeter is not connected with the circuit in a series. Okay, that's why means it is not measured throughout the potential difference through the circuit. Okay, next ammeter. Ammeter is a device it is used to measure current in a circuit. Okay, so next one is battery. How does battery maintain potential difference between the 2 points? We know having battery consisting of two electrodes, chemical having positive ions, negative ions. Positive ions moving one of the plate. Negative ions also moving towards the plate by a chemical force. Chemical force exerts some force on the positive ions, negative ions. These positive ions are moving left side, negative ions moving right side. These positive ions moving towards the plate, and it will accumulate on the plate. That plate will become a positive plate. Means and negative ions moving towards another plate, it will accumulate on the plate. That plate will become a negative plate. That is a cathode. This chemical force. Depends upon chemical, and this is sufficient charges are accumulated in the plate. These ions are in the motion. It experiences a one more force, that is electric force. This electric force depends upon sufficient charges are accumulated on the plate. Fc greater than Fe means still electrons are positive ions moving towards the one plate. Negative ions are moving towards the other plate by a chemical force. Fc is equal to Fe means positive ions, negative ions are not moving towards plates. That is a new battery. That condition is new battery. So we buy battery from the shop. The second situation. That's why battery maintain constant potential difference between the 2 points. Why does the battery discharge when positive and negative terminals are connected to the battery? Means a battery means the wire having number of free electrons. That free electrons are moving towards the positive terminal of the battery. Positive terminal of the battery. So this negative ions will reach this negative ions accumulated on the positive plate and positive charge decreases. That's why chemical electric force decreases. Chemical force increases. Chemical force puts the negative charges from positive plate to negative plate, and the more repulsion force between the negative charge to negative plate, this negative will repel to the another negative. So that negative charge will enter into the wire. The electron is traveling from positive terminal to negative terminal to positive terminal by a chemical force or electric force. In a wire means electric force. In a battery means chemical force. Chemical force is acting. The negative charge is moving from positive terminal to negative terminal. In a wire, electric force is acting from negative terminal to positive terminal. Positive terminal, the electron moving in throughout the circuit. That is the battery charge. Battery discharge. Next to Ohm's law. Next to Ohm's. So what is the Ohm's law? What is the Ohm's law? Is the Ohm's law. So what is the Ohm's law? We know to show that. To show that V by I is a constant. Is a constant. Constant for parameters. This is A. This is our A. What is our A? To show that V by I is a constant for the parameters. Next to the circuit diagram. Circuit diagram. Circuit diagram. Material. Material required. Material required. Material required. Material. Circuit diagram. I need to know. So material required. What I need. This is a magnet. Magnet wire. That is a magnet. Magnet wire. Magnet wire. Next. This is a battery element. Battery element. Battery element. Battery illuminator. So this is a battery illuminator. So next to this is a rheostat. This is a rheostat. 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 So next to this is ammeter. This is a ammeter. Meter. This is a voltmeter. 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 This is a switch. This is a switch. Switch. Next, I'm taking the connecting wires. Connecting wires. Connecting wires. This is a connecting wires. So next, processor. Next, processor. Next, procedures. 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 Procedure. a processor means you see that processor. Processor means so positive terminal means positive terminal of the unit. This is a positive terminal of the battery is connected to. It's a negative terminal of the ammeter. Ammeter. This is a positive terminal of the ammeter is connected to. This is a manganese wire. So this is end is connected here. This is end is connected here. This is end is connected here. This is what it of the voltage is connected here. The end of the voltage is connected here. The circuit is this is it. Now circuit is ready. That is the process. Now this is situation. So what happened? This situation. Situation. Enough. Now circuit is running. What we are going to show is here serial number, potential difference, current in amperes, V by N is a constant. V by is a constant. V by is a constant. V by is a constant. And I'm taking the radius to right. This is a elemental range. This is a elemental. This is a battery elemental. Battery. This battery elemental I'm taking 0 to 6 volts. 0 to 6 volts. I'm taking the 0 to 6 volts. 0 to 6 volts is this one. But I'm applying the voltage first is 0 to 2 volts. First one. 0 to 2 volts. 0 to 2 volts. And the switch is closed. Switch is closed. Current flows from higher potential to lower potential. Current flows through this wire. Current flows through this wire and reaching to this point. Some part of the current flows through this point. Some part of the current flows through this point and reaching to this point. Both currents are combined and flows through this point. This is a resistor and will up to this place. This ammeter this is ammeter. It is used to measure current in a circuit. It uses the current. How much current is current is 0.12. This is a voltmeter. This is a voltmeter. It is used to measure voltage across magnetic wire. This is a magnetic wire. Magnetic wire. So, what is the use of voltmeter? Voltmeter is a device. It is used to measure voltage across magnetic wire. So this voltage is 0.0. Next, the second situation, voltage is better. I'm increasing the voltage 0 to 4 voltage in battery. What happened? The current flows from higher potential to lower potential. Current flows from higher potential to lower potential. Current flows through this wire, current flows through ammeter and reaches to this point. The current can be divided into two parts. One part of the current flows through this wire. Another part of the current flows through this ammeter and reaches to this point. Two currents are come out and adding the two currents and flows through this resistor and reaches to this point. This point. This ammeter, this is voltmeter. Voltmeter gives the voltage across magnetic wire. The value is 0.5. And this voltmeter gives the electric current in a circuit. The current is 0.2. 0.2. Assume it. Just assume the values. Assume the values. Next, I'm increasing the voltage 0.5 voltage. This is some battery voltage. This is some battery related voltage. Okay, this is a 0.5 voltage fixed here. So what happened here? Current flows through ammeter and reaches to this point. Some part of the current flows through this wire. The remaining part of the current flows through this wire and reaching at this point, and the current is flowing through this wire and reaching to here, reaching to here. And this ammeter gives current in a circuit. This voltmeter gives voltage across magnetic wire. This is a voltmeter. It is used to measure potential difference across this magnetic wire. The voltage is how much? The voltage is 0.75 and current is 0.3. That is 0.3. This is a balance. That is a balance. Next, we have to calculate. So this is a 0.3 by 0.1. This is a 0.5 by 0.2. Voltage by current. Voltage by current. Voltage by current. 0.7 by 0.4. 0.2. I will say 0.3 by 0.12. This is a 2.5. This is 0.5 by 0.2. This is also 2.5. So this is a 0.75 by 0.3. This is a 2.5. 2.5. This is a balance. This is a balance. You see the three situations. Three situations. The first thing here, V by is a constant. V by is a constant. V by is a constant means V directly proportional I. We are going to write V I by constant V directly proportional. You see the first case, first situation 0.3, 0.12. This is a 0.12, 0.3. In this circuit, and this is current. Almost current flows in this wire. This is current. Almost current. This is a 0.3 current in this wire. Here, potential difference. What is the potential difference here? First one, this is a potential difference is 0.1. 0.1. In voltage is 0.2 voltage. 0.2 voltage. Here, this wire carries 0.3 amperes. 0.3 amperes. This is a 0.12. Here 0.2 voltage. 0.2 voltage is applied across the two ends of the connector, two ends of the circuit, and the wire carries 0.3 and voltage across the magnetic wire is 0.1. 0.1. Suppose the wire carries 0.3 and voltage across the magnetic wire is 0.1. But what is the resistance of magnetic wire? Resistance of magnetic wire is 2.5. So next to 0.3, next 0.5. So current goes on increase. Voltage also goes on increase. But what is the resistance of magnetic wire? What is the resistance of magnetic wire? 2.5 in this situation. Next third situation, current goes on increase, voltage goes on increase, but the resistance of the magnetic wire is 2.5 at a constant temperature. At a constant temperature. So this temperature is constant. Temperature of the magnetic wire is constant constant. You see the situation, current goes on increase, voltage goes on increase, but resistance of the magnetic wire is constant. Resistance of the magnetic wire is constant at a constant temperature. Voltage, current is goes on increase. Potential difference is goes on increase. Current is goes on increase. But resistance of the magnet wire is constant. Resistance of magnet wire is constant at a constant temperature. Constant temperature. So V means what we are calling so potential difference. Potential difference between two ends of magnet wire is directly proportional proportional to proportional to current passing through it. So, potential difference between two ends of magnet wire is directly proportional to current passing through it. Current passing through it. Proportionality. This is a proportional. Proportional to the current passing through it. This is a conclusion. This is a conclusion. This is a final. This is a conclusion. This is a conclusion. So what is a conclusion? So this is a potential difference between two ends of magnet wire is directly proportional to the current passing through it. This is a conclusion. This is a conclusion. Conclusion. And that is a conclusion. That is a conclusion. This is so we have to draw the graph. Draw the graph. So we have to draw the graph. That it is constant. We have to draw the graph. I is along y-axis. X is along. This is a voltage along x-axis. Current is lies along y-axis. Y-axis. You see the 2.5, 2.5, 2.5. This is a graph. Straight line passes through the origin. Straight line passes through the origin. That is a graph. This is activity. Activity 1. This is a lab. This is a lab activity 1. Lab activity. Next a second. Next a second. Next, the second one is what is the second one? To show that V by I is a not constant for the LEDs. Metal required, magnet wire not required. LED, battery inverter, resistor, armature, voltmeter, switch, connecting wires, very required. This is replaced by the magnet wire is replaced by here. So this is a LED light. This is a connected. So this is what terminal is large terminal that is connected to positive terminal of the battery. This is short terminal which is connected to the terminal of the battery. Circuit is closed. Circuit is closed. Same procedure, we are taking the reading 1, 2, 3 readings. Potential difference 0.3, 0.5, 0.75. Here, this is the temperature changes. LED lights, temperature changes. Temperature changes in all things. Temperature changes means value it changes. So this is a value which we are taking first we are taking 0.2 voltage applies across the LED. It gives 0.3, assume 0.3 and voltage across this point is 0. This is okay 0.12. Next second situation, what we are taking and 0.4 voltage is applied across across the LED. So ammeter gives reading is 0.5. This is we are taking 0.4. This is I'm taking reduced volt. Current reduced current is 0.1. 0.1. 0.1. So next voltage 5 voltage applies across the LED and the current is what is the potential difference across the here 0.75 but the current is what is the current is 0.2 ampere. Just assume it. This value is assume it and you take detect what is the value of this one is a not constant. Not constant. Not constant. Not constant. For this one 0.5, 0.5 by 0.2. This is a 0.1. I'm taking this is a 0.2. Now this is a new value 0.5 by 0.1. 0.1. This is a 5. So here next 0.75 by 0.2. This is a 3.75. 3.75. You see the first situation. What is the resistance of diode to control? Next second situation, resistance value increase. Fine. This is a 3.75. So what is the meaning of this one? You can take it. This is a 0.4. This is a value is 0.1. You can take this is a 0.75. 0.75. This is a 0.2. This is a value is 0.75, 0.2. This is a value is 3.75, 3.75. This is a value 0.4. This is 0.1. 0.4 by 0.1 is this is a value is 5. You see the first situation. In the first situation, 0.3 and 0.1. So this is a potential difference across. This is a potential across the LED, and the current is 0.12. But the resistance of LED is 2.5. The second situation, current potential difference goes on increase, and the current also goes on increase. But resistance of LEDs increase. Resistance of LEDs increase. Next, potential difference goes on increase. Current also goes on decrease. So what happening in this situation? And resistance of LEDs increase. Resistance of increase means what is the temperature? Temperature also changes. Temperature changes. Resistance of the LEDs also changes. LED also changes. That's why we're getting the graph. So I is along y-axis, B is along x-axis. We draw the graph. We are getting the curves. This is a curve shape. We are getting the curve shape. That is a graph we are getting. Okay, so we have the limitation. Limitation of Ohm's law. Actually, limitation of Ohm's law. What is the limitation of Ohm's law means? Limitation. Actually, based on the material, classified into two types. Based on material or classified into two categories. One is Ohm's law. One is ohmic material. Another one is non-ohmic. Those which material obey the Ohm's law is called as ohmic material. That is a metal example. Example is metal, all metals. Those which material does not obey Ohm's law is called as non-ohmic. Non-ohmic, for example, semiconductor like silicon, germanium. So Ohm's law is not valid for gaseous conductors. Ohm's law is not valid for the semiconductors. Ohm's law is not valid for the silicon, germanium, vacuum conductors also. Okay. So Ohm's law is valid for the ohmic material. That is example is metal. That is the limitation of the Ohms. Limitation of the Ohms law. Next, resistance. What is the meaning of resistance of the conductor? Resistance of the conductor. Resistance of the conductor is defined as opposes flow of electrons in a conductor. Is called as resistance. 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 What is the meaning of resistance? I'm going to define resistance of a conductor is defined as opposes motion of flow of electrons in a conductor. In a conductor is called as resistance. But what is the resistor? Resistor means resistance which the material which offer resistance to flow of charges. Flow of charges is called as resistor. That is a resistor. That is a next electric shock. Next topic is electric shock. Electric shock. Next topic is electric shock. Electric shock. Electric shock. Electric shock. Electric shock. So, what is the meaning of electric shock? Actually, the body. This is a one person. This is a person as a. This person as a resistance. Resistor. The body has resistance. Just let us assume that the human body is a resistor. Human body is a. This is a human body is a resistor. This is a human body. Human body. Let us assume this is a human body. Human body is a resistor. Human body is a resistor. So the resistance of human body, the resistance of a human body varies from varies from 100 ohm to this is a dry wet with salt water to 5 lakhs ohm dry. So dry. Skin is very. If the skin is, if the skin is dry. Skin is dry. So let us assume human body is a resistor. Human body is a resistor. So next second point is second point. Resistance of human body varies from 100 ohm to 5 lakhs ohm. 5 lakhs ohm. For example, this is a body. This is a battery. This is a battery. This is amplitude, positive, negative. This is one hand. One hand is touched with the positive, another hand is touched with the negative. The circuit is closed. The circuit is closed. The circuit is closed. The circuit is closed. This battery voltage is voltage of battery 24. 24 voltage. 24 voltage. The current flows from high voltage to low voltage. Current is flowing this way. Current is flowing this way. Resistance of this body is resistance is equal to 1 lakh, 1 lakh, 1 lakh. But what is the current? So voltage is 24, resistance is 1 lakh, 1 lakh. But what is the current formula? I is equal to V by R. I is equal to V by R. So voltage means 24, 1 lakh, 1 lakh. 0 cancel, no cancel. So I is equal to 0 0.00024, 1, 2, 3, 4, 5. This is ampere. Current. This is a small current. Small current. This is a small current. This is one person. One hand is touching to the positive terminal. Other hand is touching to the negative terminal. The circuit is closed. This is a circuit is closed circuit. Closed circuit. Closed circuit. Circuit is closed means current flows from high voltage to low voltage. Or negative means it flows from negative to positive. Current flows from positive to negative. Negative. So this is I is equal to 0.00024. This is ampere. This is a small current. Small current. This is a small current passing through this body. Passing through this body. This current does not affect the functioning of organs in a human body. Human body. This is a small current. This current is passing. This current is passing human body. This current passing through the human body. This current does not affect functioning of organs in a human body. Human body. So next, this is a person. This is a person touching the light. This is a light wire. This is a wire. Electric one. This wire carries positive voltage. This wire carries zero voltage. Zero voltage. This is one hand is touching to this point. This is another hand is touching here. Touching here. For example. This is example. This is a 230 voltage. This is 0 voltage. Current flows from high voltage to low voltage. This is current is flowing. So current is flowing. Now voltage is what is the current? I is equal to V by R. V by R. V is equal to what is a V? So V means 230 voltage or 240. You can take the 240 voltage. 240 voltage. And my current is resistance of this human body is same. Human body is same. 1 lakh ohm. 0 cancel, that is I is equal to 0.0024. 1 yes, 0.2. This is a current. This is a current. This current flows. This current flows through the body, human body. This current will disturb to the functioning of tissues. Tissues. This current is this current passing through the human body. Human body. This current will disturb to the tissues. This current will damage to the tissues. 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 Okay. So this is current continuously passes. This current is continuously processed. What will happen in this situation is this is current. Now you see the in this situation, current is this is current. This current is passing through the human body. This current is passing through the human body. This current will damage to the tissues. Tissues. Next, this current is continuously flowing through the body. It will damage the more tissues. More tissues. That's why the resistance of human body decrease. The resistance of human body decrease. Resistance decreases means current flow is increases. This is reaching to the, this is I is equal to 0.07 amperes means this is very dangerous. This current is flowing through the human body. Human body. This current will damage to the functioning of organs in a human body. Human body. This current is flowing through the human body. It will damages the functioning of human body. Functioning of organs in a human body. It is this current is flowing in the human body more than 1 minute, 1 second, 1 minute. It will the person will be died. The person will be died. This is will be died. The person will be died. Okay, now this is electric shock. Electric shock. What is the meaning of electric shock? Means disturbance in a human body is a felt. Felt is called as electric shock. Electric shock. Disturbance in a human body is felt is called as electric shock. Electric shock. This is a current. This is a current. This is a current. This is a current. This current is passing through the human body. Human body. This current will damage the tissues. This current is continuously flowing through the human body. This will be damaged to the more tissues. More tissues. The resistance of the body decrease. The current is the more current increases. The current is current goes on increases. That current is flowing through the human body, and it will be more damages. More damages. And resistance of the body goes on decreases. The current goes on increases. The current goes on increases. That is flowing through the human body. The current will be reached to the I is 0.07 means this current is flowing through the human body more than the 1 minute. What will happen? The person will be died. The person will be died. This is a electric shock. So we have the electric shock. Next, this is electric shock. Electric shock. Okay. Suppose, for example, like this is an electric shock. You know, this is a bird. This is a bird. This is a bird. The bird is standing. This is a wire carries 240 voltage. This wire carries 2 voltage. 0 voltage. So this is situation number 1. Example. Next example is suppose this is a wire. This is another wire. This wire carries 240 voltage. This is wire carries 2. This is a connecting one. This is a wire. Conductor. Wire. Conductor wire is connected here means current flows from high potential to low potential. This is of current flow. Current flow. In this situation, current flow. Current flow. In this situation, here you can touch this point, at this point, any point on the wire, what is the voltage, any point on the point. So this is any point on the wire. What is the voltage? 230. At this point, what is the voltage? 230. this point, what is the voltage? 230 voltage. So what is the potential difference between this is A point, this is a B point, VA minus VB? What is the 230 voltage, 240 voltage, 240 voltage, 240 voltage. This is a B point. Here also 240 voltage. So this is our A point. What is the potential difference? 240, what is voltage? Potential difference VM minus PV is equal to what is voltage difference? Zero. So current is passing. Current is passing in a bird is zero. Current is passing in a bird is zero. The bird does not get the shock from the live. Live what? The bird does not get any shock from the wire. From the wire. This is a reason. This is a connecting wire. This is a connecting wire. But this is a live wire. This is a neutral wire. Neutral. This is a phase wire. Phase wire. This is a neutral wire. Neutral wire. This is a phase wire. So phase wire carries 240 voltage, but neutral wire carries 0 voltage. This is a phase wire. This is a neutral wire. Connecting wire. One end of the wire is connected here, another end of the wire is connected here. Current flows from high voltage to low voltage. Here current is passing from one connector to another. But in this situation, one leg, so this is a bird leg is on the wire. This is another leg of the bird. That leg is on the same wire. At this point, 240 voltage. At this point, as the wire getting 240 voltage. What is the potential difference between the two parts of the bird? 0 voltage. 0 voltage means the bird does not carry any current. Does not carry any current. That means the bird does not get any shock from the wire. That is a very easy. Okay, this is a electric shock. This is electric shock is low. Shock is low. Next, here have the situation. We have the situation laser. So we have the table. So this is a current. This is a FH. This is a FH. So current is how much? 0.00. So next 0.01 means can be fed. Can be fed. Can be next 0.005 is painful. Painful. So next 0.010. 10. So muscle contractions. Muscle contraction. Next 0.015 causes loss of muscle control. Next 0.070. 0.07 causes serious destruction. This is a construction. This is a current in amperes. Current in amperes. 0.001 can be felt. 0.005 is painful. 0.010 muscle contractions. 0.015 causes loss of muscle control. 0.07. This is 0.070. So causes serious depression. So maybe it will be properly. Okay, maybe person will be done. The last situation, the person will be, this is more than 1 second, more than the current passing, the current passing. So this is the current 0.07 is current is passing through the human body more than 1 second. The person will be died. The person will be died. Okay. So this is the class. Okay. Tomorrow I will explain next topics. Thank you. Thank you very much.